Dhanashri, who is the next one?
Sir, Tanay Jaiswal.
So shall I make him the presenter?
Yes, sir.
Yes, sir. Hello.
Yeah, you can start.
Okay, so we will be just continuing the previous problem of Dhanashri's. So we'll go to File and New. Then, okay, so I'll just quickly do what Dhanashri has done before. The task here would be to find earth pressure. This part would be second since Dhanashri has explained the first part. We can write here to find earth pressure of a given problem. Customer, you can write it as XYZ. Author would be yours name. The date will be displayed here, which would be the default date of today's. And you can write project ID if you're working at some site. I'll just write my roll number here, 47. And then we can go to settings. Okay, one important thing. Since this software is made in Europe, you have two system of units. So we'll just select metric. We'll go in settings and we can see here the methodologies which are recommended by Indian code. I have by default selected Indian code, so it is Indian standard. But if you want to change the code, if you have just downloaded the software, it will be showing you the American code, sorry, the European code. So you can change it from settings administrator. If you want to edit something in this, so you can click here in edit, and you will be shown all the methods which are mentioned by the code which you can use. So for active earth pressure calculation, we have Coulomb's method. For passive earth pressure calculation, we have this method. But if you want to change it, you can change it too. The best method by the code is recommended. If you want to make earthquake analysis, you can change it from here. You can go for yours method. And the safety factors again would be all as per the standard codes by India. We will go to the geometry now. We will have to edit the geometry since the problem said it would be 4 meters of height. So we'll just edit it as 4. And since there is nothing mentioned about the inclination of wall, we'll just keep the coordinate x as 0. And now it is 4 meter. The top coordinate is 0, 0 because software measures it from top always. And the bottom coordinate is 0, 4. Then you can go to profile. If you want to make inclination, you can make this bottom coordinate as like 1.5, so it will be inclined, you can see here. But since we have to make it vertical, so we'll just keep it as 0. And here it is as before. When we'll go to profile, actually we have to mention the terrain condition here. You can directly mention the terrain condition by applying GPS. So it will scan the area and it will already give you the terrain condition. But since nothing is mentioned about it in problem, we'll just go skip this part. We'll go to soils. We will have to add the soil. So just clicking on add, the name would be cohesionless soil. Okay, gamma given in the problem is, if you have BC Punmia, you can refer to page number 515, example number 20.4, which is just an extension to the previous example by Dhanashri. The example says that in example 20.3, if the water table rises behind the back of the wall to an elevation of 1.5 meter below the top, determine the total active pressure and its point of application. Take submerged weight of sand as 12 kilonewton per meter cube. Assume that there is no change in angle of shearing resistance due to submergence. It is just a continuation of earlier problem. So we will take the bulk unit weight as 18 kilonewton per meter cube. Angle of internal friction, it is given as 30. Cohesion of soil, we have been given 0 since it is cohesionless soil. The angle of friction structure soil will take at 0 because nothing is mentioned in the problem. And the calculation mode of uplift would be standard. Saturated unit weight of soil, since nothing is mentioned, and we have given that we have to take unit weight, submerged unit weight of sand as 12 kilonewton per meter. And we know that submerged unit weight is equals to gamma sat minus gamma W. So if we put saturated weight as 22, then the submerged weight will automatically come 12, since gamma sat minus gamma W is gamma submerged. So we'll put here gamma sat as 22 kilonewton per meter cube. Another thing, the software takes the density of water as 10 kilonewton per meter cube, not 9.81. So there may be a slight difference in the final answer, but we'll cross check it from the book. So gamma set is 22 kilonewton per meter cube. The pattern category, we'll just keep it as GEO. You can search if you want to do any other pattern category. The soil, in the classification of soil, the mentioned soil categories from 1 to 16. Then since we have selected cohesionless soil, we will be selecting 9 number, which is sand. And you can assign any color if you want. I'll just go with the brown. And just automatic color, you can change the saturation percentage from here, but let's keep it as it is and add. So we can see in the background it has been added, and all the details which we have put it earlier is displayed here. We'll just cancel this, and since we have inputted every information, we can go to the assign. As we go to the assign, you can see that color has been assigned to the figure, and everything which we have mentioned earlier has been assigned to the given geometry. Now we will find the terrain conditions. Since it is mentioned that horizontal backfill is provided, we'll go with the first option. Again, there was something I forgot to mention. In soils, if you go, I'll go to the cohesionless soil, edit. Angle of friction between structure and soil, we have taken it 0. That's because in the problem itself, they have mentioned that the surface of the backfill is smooth. So the angle of friction between structure and soil would be 0. Okay. We were on terrain. So the terrain which we have assigned is the first one, where beta is equals to 0. You can see here. Then we will be taking water pressure 2 in the account. So we will be taking the second option here, and the groundwater table behind construction they are asking. So it is given in problem that it is 1.5 meter below the top. So it is okay. We have put 1.5 meter here, and we can move forward now. Surcharge, in the earlier problem which Dhanashri mentioned, the surcharge was 36 kilonewton. So we'll just add it here, write surcharge load. Type would be the surface, because they said in the problem itself that there is uniformly distributed surcharge load of 36 kilonewton per meter square intensity over the backfill. So it would be, type would be surface, and the type of action you can change it from here permanent or variable or accidental, we will just go by permanent. The magnitude is 36 kilonewton per meter square. Add, and we can see in the background it has been added. So just cancel it. Again, it has been added. Now, if you want to do earthquake analysis, you can do it from here by clicking analysis earthquake and putting all the information. Since nothing is mentioned in the program, we just skip this part too. Stage analysis is for what type of condition do you want to analyze your structure. So there are different conditions given like permanent, transient, accidental, seismic. We'll just go with permanent. And now if we click on analysis, we will get a detailed analysis of the structure. So we can check the accuracy of the software and the book. So the length of the structure which we had assigned is 4 meter, and overall force is 121 kilonewton per meter. And if you look at problem number 20.4, the total pressure is also 120.41, which is very close, and the difference is created because the software takes the unit weight of water to be 10 kilonewton per meter cube, but the book has taken it 9.81. So there is a slight difference between the answer. So in the book it is given 120.41 and we have got 121. The depth of the centroid, the book has given 1.5, but in the book they have computed from the bottom of the height of the wall. In the software it computes from the top of the wall. So if you minus 2.5 from the total height, that is 4 minus 2.5, you will get the height 1.5, which is the distance z dash in BC Punmia. Also, you can see the stress at the top face is 12. If you have BC Punmia, you can refer figure 20.15. The same figure is mentioned here, but in the book it is divided into it is divided according to the pressure intensity due to surcharge or due to dry soil. It is in the software it is given as effective diagram, so they have not distributed it. You can see that at the top the pressure intensity is 12, and in the bottom actually the P5, which is lateral pressure intensity due to water, they have taken the intensity of water. They have taken the intensity of water, weight of the water as 9.81. If we take it 10 and make the calculations, the bottoms comes out to be 12 plus 9 plus 10 plus 25, which is 56, and that is given here. So at the bottom, the intensity of pressure is 56 kilonewton per meter square. In this table, you can see that they have distributed it as active pressure, then the water pressure, and the surcharge load. So if you have BC Punmia, then you can see that active pressure is given as 41. It is negative because the pressure will be acting in the opposite direction, which is from right to left. Therefore, they have mentioned all the negative signs here. And you don't have to do any edit about coefficient of friction. In the earlier presentation demonstration, our senior Sanket Raut have just edited the coefficient, but we don't have to edit it because the software takes the coefficient of active earth pressure account in itself when we put the angle of friction. So there is nothing to change here. If you want to find the passive earth pressure, you can go to passive earth pressure from here compute, and you will see the passive earth pressure too. Just go to active. We'll just go to active pressure again, and everything is same according to the book. So we can conclude that software provides accuracy. It is easy, plus we can get the direct result without wasting our time. So softwares like GEO5 always helps us in faster calculations. Again, if you want a complete documentation of what we have done, you can click here. It says prints detailed documentation. You can just click here and you will get a complete documentation of what we have done here. The task was to find earth pressure, part was to description was to find earth pressure of the given problem, customer XYZ, author Tanay Jaiswal, date and project ID. Settings was according to Indian standard. Active earth pressure calculation was done by coulombs, passive earth calculations and other calculations was done by respective methods. I told you if you want to change the methods, you can change it. by just going on edit. This was the geometry of our structure, and the basic soil parameters that we have put. You can see here submerged weight of soil, weight density has been already computed as to be 12 because we have put the gamma sat there 22 kilonewton per meter cube. The angle of friction is 30. Everything is just as we had assigned it before. Here are all the details. Here is the resultant forces, which is 121 kilonewton per meter. Application point is 2.5, and the total vertical pressure is 0, and total vertical compression from top to of construction is 0. We can also change the orientation from here if you want to, and you can also write your name and the details of the project. We'll just go to page setup, and you can edit it from here, everything. But unfortunately, for this is the demo version, we cannot save or do anything. In the original version, if you download and pay the fees whatever they are asking, you can actually take this file to Microsoft Excel or Microsoft Word and just add it into your original documentation. If you want to print a diagram, you can go to the next option, which is just by side of it, where you will see the diagram. So this is the diagram. Orientation landscape. Okay. So this is the diagram. And you can add it to your documentation if you want to. Okay, so these are the point of application of individual pressure. Like active pressure would be acting at 2.51 from the top of the height. Water pressure would be acting on 3.17 meter from the top. Surcharge load would be acting at 2 meter from the top. These are the individual intensities, and the total overall force is 121. Okay, so everything has been explained. Just a minute, I'm seeing if I have left anything. Okay, so this is all. And if you want, you can see the result and compare it with the book. Everything is same, nothing is different. If there are any questions, they are most invited. Hello?
Yes, any questions are there, Tanay? You can ask them.
If there is any questions, please ask. If you put the data correctly, everything would be as in the book. You can also check the accuracy of the software with the book. Example number 20.3 and 20.4 on page number 15513. You can go and check the diagrams. Even if you are doing it in future, you can always contact me. My email ID and WhatsApp number has been displayed on the seminar screen.